Yes, okay, Amir, please join me here on the stage. So everybody, please help me by welcoming Amir Shaked. Yeah. And I want to tell you a couple of fun facts about Amir. So Amir is the VP, Senior VP of Research and Development at Perimeter X, and he's here to talk about hacking and fixing the CSP standard, the Content Security Policy Standard. But what you didn't know about Amir is that other than being a security pro, he also has a degree in physics. Amir, quickly, what is pi after 5 points after the 5 numbers after the point of pi? 3 point.
I really don't know.
Oh, okay. Well, I wanted to tell you he got his degree at Tel Aviv University, but since he didn't know it, you got it in another university.
Yeah.
So he has a degree in physics and an MBA, both from here, from Tel Aviv University. And I asked him for his hobby. He says he likes Python 2.7. So there you have it. Please welcome Amir to our stage. All right.
See if it works. It works. Excellent. Hi, everyone. Great being here. So much fun doing a live event after such a year with only Zoom and seeing on myself. We're going to talk a bit about CSP, how we might try to fix it. And part of the purpose of this talk is to invite everybody here to try and dive in, find more problems, and try to contribute to the CSP 3 standard to make it better secured and improve everyone's security. Along the way, we'll just demystify a few things that you might have already known or not. Like Karen said, my name is Amir Shaked. I lead the research and development at Perimeter X. I've been around security for many years. I avoid warranties. I am a lifelong hacker, aspiring father, trying to teach them to break stuff as well. And with that, we'll dive in straight to, I think, a hypothetical story, but if somebody had such a case in his own work, it would be very interesting to see. So I wanted to enable CSP on my website, on our own website. We read and understood the spec completely. It's very well and easily understood. We added the header with report-only mode, and then a day later, we marked all the resources, all the notifications that we got, all the violations, supposedly violations. We cleaned everything, we rolled it out. We had 0 issues with the website, and everything worked fluently. I think no one said ever. Anybody here tried to use CSP as a technology? 1? 2? Okay. That's pretty much the stats that we see also in the internet, so works along. Now, it really is a very complicated standard, and it has a lot of problems along the way on trying to implement it and use it. What is really frustrating is that a real story that we did encounter and helped with was something a bit differently. So we got a call from the company. We got a call from the credit card company telling us they see a lot of credit cards being used on some website, being circulated in some forums, being used, and they correlated all those credit cards to a specific website, and they're talking with that company, trying to understand what happened, reviewing all the security possibilities along there. And then what we see is they configured everything properly, everything was well-defined, but there was a fundamental flaw which they did have no control over, and that's the supply chain. Some third-party vendor that got hacked. That specific case was a chatbot they were using. They got hacked. Their source code was replaced with an additional code, and that code worked and basically exfiltrated data from the website, digital skimming if you want, to an external entity. Now, it was whitelisted, and everything was supposed to work properly, but whitelist doesn't mean that you will not be able to exfiltrate information. And let's go here. And from there, I want to talk a little bit about CSP. What does it mean? How is it used? And then we can see a few of the cases where it breaks down and has issues. So CSP as a standard, it's actually been around for a long time. It was first conceived in 2004 by Robert Hansen. He gave the name Content Security Policy. Only around 2012, it actually became a standard by W3C that websites started to use and implement in their own infrastructure. And the common version, version 2, which is the official one, latest version 2016, that's the one that most browsers support. If you want to see which kind of features specifically, it actually varies. So nobody really implements the entire standard, like any security standard. Can I Use is actually a great resource to see which specific component of the standard is actually being supported. And the version 3, which started around 2015, is still a work in progress. So it's not finalized yet, and that's being worked on. Now, before I continue, if anybody has any question, you can just shout, and I'll stop and let you ask it now. We don't have to wait for the end of the talk. OK, so very briefly, how does the policy work? What's the standard? It combines two headers. One is content security policy, and the other is content security policy report only. Basically, implementing this exact same standard, but not blocking anything, just reporting the violation if there is a report destination URL where you can send the information to. So if we look at this, we can see a pretty simple description of a policy saying the default source is to allow any content to come from the website. Source code, JavaScript code, can come from the website itself and a specific domain, CDN.js in this case. And the report URI on any violation will be to the website/CSP logging. And then in this case, this is two examples. The image and the script will work because they're coming from an allowed destination. And if everything works properly, the last one will not work because it's trying to download the script from an unauthorized destination, basically not within the policy. So the entire concept of CSP is a whitelist method where you define what is allowed. If something is not allowed, it will not work, which is great in theory. Somebody here tried to manage IP tables policies? Yeah, yes to both. You have a question. Louder, please. Oh, I get your question. So actually, this is a server protection. Because this is a, CSP can be defined in two ways. I actually didn't thought of mentioning that. One way, which is not recommended, would be within the HTML tags. You can define the policy. The other would be the HTTP header itself. So the server is the one you need to protect, defining and releasing that header. So that's the place where you need to make sure that sends the right header, the server. Yes, if somebody changes, if somebody has control over, it's not just the servers, but you need to change specifically what's configuring the HTTP headers. Because in big websites, you have a chain of elements. Say the headers come from the front edge on the CDN, then it will not be able to manipulate that, even if somebody defines something down the stream. So it really depends on where you control and how the website is specifically defined. There was another question here? Shout because it's hard to see. OK, so that's around that. It's most commonly practiced is to define it with HTTP headers. I really don't recommend defining it within the HTML. It's really hard to maintain. OK, so I don't know about you guys, but being a hacker, seeing a specification just calls out to let's try and see where it breaks and what you can do with it and different methods we can play with it. First of all, it's not fully defined. Even with all the rich documentation that I invite everybody to read, it's not fully defined. There are items that varies, what the reports hold, when to report, and I'm going to show some example of that. And that leads to inconsistency when you're trying to analyze what it is that you're viewing. The implementation itself may be lacking. Just try searching CSP in the CVE database and see where there are gaps in browsers themselves. and it's very usage dependent and can be abused. And I'm going to give examples on all of these, how they're actually being exploited. So let's start with numbers. We've seen this as a security technology. It's been around for a long time. If you actually try to see what kind of security methods are being used by websites, we can see the numbers. Do you people know HTTP Archive, the amazing database? It's an amazing resource. I'm glad to see only a few hands, so I invite you all to try and dive in. It's an amazing resource. They scan, in the past 3-4 years, they've been scanning 4 million websites every month, storing a lot of information about that. If you're trying to do analysis on web usage over history, that's a very rich information where you can try and see a lot of things. What I was specifically looking at was how the different HTTP headers were being reported by websites. And what we can see here, the top 3 are actually the one with the dashes. They're actually deprecated, but still growing with numbers. So CSP is replacing that, but still people use deprecated security headers within their infrastructure. And then the bottom 3, it's CSP. See, I don't have a way to shine on this. I'm also colorblind, so I'm not sure which colors I'm going to say. So the lower one, that's report only, and two after that, that's the content security policy itself. Now, it's only the mentioning of the header. It doesn't say what's actually being defined, and we're going to see a bit more numbers around that. What is, I was happy to see that over time, and I've been analyzing this in the past few years, the numbers did grow. So we were around 10% now of CSP usage, when it was much lower in the past. So it seems like a positive trend, but when looking at those, comes down to about 700,000 websites as of last June, last month. What are they actually using? We're going to see the following directives. So what is the policy? We saw before several examples of directives. These are the actual directives being used by websites. And what do they mean? The first one, the frame ancestors, that basically mean if you can embed a page within a frame or an iframe, and it's just replacing a previous security header that we saw, which was the one of the most common. The second one, to upgrade insecure requests, again, means moving all HTTP traffic to be HTTPS. And that as well is replacing a deprecated security header that we saw in the previous slide. So if you look at that, we see that most of the websites implementing CSP are just replacing the different security headers with the new version. They're not implementing the full scope of what you can do with this technology. And the following ones, pretty low numbers, those are the ones that are actually interesting. The fetch directives, which tells us where we can get content from and where we can send it to. These are the interesting ones we can really use to secure our website. They're not being used that much. And I believe part of the reason is the complexity of using the technology within the website, and that is pretty low numbers. So it is still sad to see. But with those actually trying to use that, we're still going to see a few fundamental gaps within the technology. I took the example of several websites, and this is frustrating. So even those trying to implement CSP, they're using the top one. The top one basically says, you can bring source, but it can be unsafe eval and unsafe inline, meaning we don't check anything. Everybody can add code to the page and run it, and we're not going to validate anything. The bottom one, which I've seen very few websites use, dictates that if there is an inline JavaScript code within the page, it has to match the specific hash. So you can't just add any type of code you want to add into the page. It has to match the exact hash. Harder to manage, but actually brings the security into fold. And like any system, looking at the directives, we said, OK, there should be around 30. Why do we see 700? And that's because people don't check anything. All kinds of mistakes. I really don't understand the last one, the go for it. It's interesting. It's been around on more than one website. I'm not sure what they wanted to do with it. But all kinds of examples. And when the directive is wrong, the policy just breaks and doesn't work. So it's as if we have nothing. So even out of those websites, not everything is actually working. The Google CSP validator is the best one I've seen to date. So if you're trying to write a policy, please use that. Wait, did it jump? No, cool. OK. So we define the policy. We define the report URI. It's JSON, so it's pretty simple, supposedly, to just read the reports and trying to understand what are we seeing. And that's the next phase of the madness. Data is not normalized at all. It's full of stuff coming from extensions and ads. And it's also unmanageable, because if you have an extension running within the browser, by design, they bypass the CSP. But if they're injecting code into the page will still report CSP violations. So now you're trying to read your own violations, and they're not actually coming from the website. They're coming from one specific user. And within the standard, there is nothing that tells you it's a user. You need to add a bit of hackings into the reporting information itself to understand which user was it that reported that violation. So it's really not helping you to analyze the information at all. And I'm not going to jump into the link, but I invite you to go to the last one. It's full of really fun examples. That's the explained one. You should look at the unexplained one. It has a lot of examples of CSP reports websites see, and they really don't understand where they come from. The last one, when we went into high scale of looking at the actual information, was browser misalignments, when the report is actually being sent and what are we seeing. And a few of the examples which are still relevant, Chrome works differently. If the report is to be blocked, they will send one report per page. Fine, that's easy. Firefox will report it multiple times per page. So now you have the differences between how many reports you see and how you're trying to analyze them. And then Safari behaves completely differently. If you have a repetitive call blocked, and it will send it, it just sends the top-level domain, so you don't even get the full page of the reporting of where it originated from. And then, of course, like any reporting service, there could be log spamming. We actually saw some interesting cases where log spamming was trying to be used to manipulate systems, but this is still, I would say, next phase of attacks, because some vendors are trying to build systems which will automatically configure and define from reporting policies what is something that should be whitelisted. You can actually spam the system and trying to abuse the machine learning to learn a specific domain as should be whitelisted. Haven't seen an example yet, but I anticipate it will happen as it's becoming more abundant. So we went over that part. The next part we wanted to look at was actually CVEs and how do browsers behave. So this is the CVEs report over the years, specifically in total, in Firefox and in Chrome. I'm going to dive a bit to one that we found a while back. It's pretty straightforward. The following code, if you look at the directive, it says that object source shouldn't come from anywhere, and skip source should only come from the page itself. And then this code should not work. It should be blocked by the browser, basically trying to create an element with a script and fetch it from a non-whitelisted domain. But then, if we add a tiny bit of hack, this is already, by the way, mitigated, so we don't have to worry. Just opening an iframe and adding it into the iframe, that worked. Now, I'm not blaming browser developers. It's really hard to build a fully protected browser and to match all the different possibilities you can have with all the different variations. But these kinds of CVEs happen all the time, and I've actually reviewed a few of the latest 2021 CVEs. They've seen breaches reappear after they were closed 3 and 4 years ago because code was refactored again. Any questions so far? OK. So let's assume we have a well-defined policy, and let's assume the browsers work well. What can possibly go wrong with this concept of policy? I asked simple questions. Again, going back to HTTP archive, let's see which are the most commonly whitelisted domains that websites use. Let's not assume anything. Let's just see what they're using, and let's see what we can do with it. So going back to March 2020 and then looking at last month, we see these domains. Here is a question for you. If we look only on the top one, does it bring you an idea what you can do with it? Yeah. Can you, louder, please? A malicious advertisement, okay. Any other idea? Yeah. Subdomain hijack, but it's www, the top one. Yeah. Yes. So, thank you. First of all, it's not just the top one. It happens again and again when you're going down the list. So it's more than just the top one. It's actually more common. And the simplest idea here was, OK, I'm looking at this information. I'm saying, sounds pretty simple. Let's just try and use the top domain, which is whitelisted, to exfiltrate data. Will it work? Will it be that simple? And the answer is, it is. Because any JSON endpoint that is whitelisted can be used for data exfiltration. And it's just Google Analytics. This is just the simplest one to try to implement this bypass. It can be with anything. It can be with trying to send tweets or a Facebook message if it's whitelisted. New Relic, you can open an account for a few dollars if that is whitelisted and use that. Any service that is shared and is commonly whitelisted because websites are actually using it can be used for the data exfiltration. So even if we did all the work of defining a well-protected policy, somebody can try and bypass it. And it's pretty simple to write the code. So we just added a few bits of lines, as you can see. This isn't even a complicated scenario. We're just doing all the information on the query string itself, not even trying to do it as an AJAX request. And obviously, it worked. We have the information. We can export it from Google Analytics. And then we have user password that we exfiltrated from a website, even though it was strict, just because Google Analytics was whitelisted. Now, we went back to the standard and said, OK, interesting. Let's dive in and see if somebody tried already to resolve it. So let's, at least with the query string itself, can we do some kind of limitation to protect it? And as you can see, by definition, it doesn't. This is a quote from the standard itself. We do not go into the query string. We don't try to validate anything beyond top-level domains. That is the only level of protection we can efficiently implement within the standard itself. So that can't be supported, unfortunately. And then we said, fine. So far, still an interesting story. Let's publish that. We didn't think it would be that big a story as itself. We published the method. It got a lot more exposure than we expected because it seems pretty straightforward. And then just a few days later, other security companies started to report on actually seeing this being used in the wild. From Kaspersky, from Sunsec, and a few other companies, reporting that they actually see this being abused. So it's not even just a story and a theory. It's just a matter of looking at the data and trying to understand, playing the game of, if we would have been the attackers, what we would have done. Looking at websites and seeing that, yeah, somebody is already trying to do that. It's just a matter of exposing the method and bringing it into light. So today, by the way, if you're going to add Google Analytics as a destination domain and go to the CSP validator tools, they will point it as a potential risk. They don't have any suggestion on how to solve it, but at least they will tell you that there is a potential risk. So that is an addition, which is an important one. OK. So if you look at the story from where it went wrong, the fundamental problem here is we're trying to protect a modern website with a lot of different elements and tools with a policy. And like I asked before, who tried to configure an IP tables policy? These things are really hard to configure well, and there are not a lot of best practices. I'm going to mention a few, but it is really problematic. And when we're defining a policy, the most common vector of attacks today that we see on modern websites is coming from some kind of whitelisted target. I don't know if you've seen, just earlier this week, CDNJS reported they had a major potential breach. Have you seen it? Nobody? So Cloudflare reported that they had a major potential breach where somebody could basically change the source code on any JavaScript placed on CDNJS. That's a pretty high-risk item. They fixed it after they discovered it. But that happens all the time. That means that code we bring into our website, which is running on multiple platforms, we didn't build it, we didn't own it. We're using a lot of different tools when we're building our system, or the marketing team adding all kinds of tags when they're just trying to improve some aspect in their website. We don't have actual full control over what's joining, and we have no control over the security of those elements. And they're being whitelisted, and they expose us to data exfiltration from both angles, from where source is coming and where data can go to, because we're using all these tools. So what can you do to make the best of it? It's still a good standard. I'm still recommending everybody to use it. I'm not recommending anybody to just avoid it. It's still raising the bar and requiring a potential attacker to try and work harder to try and breach and exfiltrate information. First of all, pretty basic, but still not that common, is just to add an identifier on the report URI. Add some kind of an identifier telling you this is a user, A or user B, so you can look at the logs later on when you're trying to understand what you're looking at. Obviously, filter the reports. My go-to here is just look at the most common, newest browsers. If you're trying to understand if your website is working well enough, ignore all the minor cases, just focus on those which are the most common. If there is a problem, that will tell you where it is. You don't need to focus on anything else, on all the long tail of noise. And the last one, which is a pretty nice hack that you can do, I haven't seen any open source system yet to do it, but it's a pretty nice method, is to A/B the policy. The way you can start is with the report-only policy, which is the strictest, allow nothing, get all the reports, and then just starting to add elements one by one to be still as strict as possible, and see with the report only what kind of reports you're using. Once you get to a position when you don't see any reports that you don't think you should get, then switch the policy from report only to mitigation mode, basically changing the header from report only to block. And that will give you all the information that you need, and then you can play with it as you go along. You can keep on iterating on the policy back and forth on portions of the users, on actual part of the sites, and then see how you can verify that both domains that you have there should be there, and that they're not obsolete. This is something that I didn't mention before. We've seen cases where the CSP whitelist has domains that were obsolete because somebody did a test, it didn't work, they added a domain, and they forgot about it because it never changed it. There is never a report on something is not needed. And the domains got obsolete and are out there to be bought. So somebody can actually buy domains that are whitelisted on websites. Not very popular one, but assume you're using startups. Sometimes they close. And if you don't remove them from the policy, somebody else can try and buy that domain and reuse that as a target. So like I said, clean up after once in a while. That's the idea behind this. And complicated, but I definitely recommend you use the nuances and hashes to make sure the actual inline code is also the one you intended. Requires a lot more work, but still something that should be relevant. And the last one, still not common enough, is to be context aware. You don't need to use the same policy for the entire website. You can be strict on different pages according to what's being run there. On the login page, be very strict. On the front page, you can allow Google Analytics. You can also decide that there is no Google Analytics on the login page and just remove that risk. You don't need to assume you need it on every single page. So this is something you can take into account when you're trying to protect it. And the last one is really, to me, the most important one. Try to contribute to W3C, to the CSP3 with comments and ideas. It's still a very important standard, and a lot of browsers are still implementing it, and it's still open for reviews. So try and hack it, trying to find new ways to break the standard, and try to find ways and ideas in order to push everything to be better, because it's protecting all of us as users in the internet with browsing those websites. Any questions? Yeah.
Yeah, so.
Welcome.
Yeah. So the attack vector that CSP is trying to prevent is if someone, server or client side, managed to inject malicious JavaScript code and you want to block exfiltration of it, for example. That's the whole point. The server sends the HTTP header, and the browser itself enforces the policy that the server defines.
So that's the basic idea behind it. CSP is mostly intended to prevent XSS. So cross-site scripting, those kind of attacks, they can come from different places, but that's the main idea behind the method. It's not only that, because one thing that we see is that the standards are trying to move all the security headers, the different headers that we have, as directives into CSP. So it's also adding more layers of protection, I would say, but it's just a matter of making it more convenient for the security person to manage one context and learn less about less and less methods that you can try to protect. Like the upgrade insecure request, for example. That has nothing to do with XSS. It's mostly about making sure the website is only HTTPS. But with that said, it's mostly around XSS, yeah.
Thank you.
I already answered that.
Ask a question, get a prize. Any other questions?
Over there.
All right.
Somebody over there.
Where?
Yeah.
Raise your hand. Oops.
Hi, can you kindly please comment about the age of XSS in view of CSP?
Can you repeat that?
What is the status of XSS attacks in view of CSP implementations?
Interesting. So I haven't seen them myself. I read a few reports, and from the reports I read, XSS is, first of all, it's still very common as an attack vector, but it is CSP is very effective in blocking that on websites that publish information on how XSS is actually trying to be abused and being blocked with CSP. So I've seen very few reports of those, but from what they're reporting, they report on very effective mitigation on various XSS.
Any other questions?
Yeah, somebody back there. I'm going to need the mic.
Do you think we could use that a new version of CSP could possibly defend against CSRF attacks, or is it that just not going to work ever?
I don't think so, because CSP is mostly intended to be the client-side part of the protection, and the CSRF tries to manage both ends. So I don't see it going into that. They're mostly focusing on the XSS part and the client-side protection, and I think that's where they should focus. It's coming to protect the user using the website.
Hi. Do you think CSP should also support whitelisting of URLs, full URLs, or not just domains? Because currently, you can just find a URL inside the domains that are already whitelisted that you can just do whatever you want with it.
Yeah, it's a good question. It's one of the items we looked at. In theory, I would say yes, but it adds a very complicated layer to the browser themselves, trying to be effective when they're trying to analyze and mitigate. So from the security perspective, I would say yes, but as a user, this might affect us in a negative way. So I'm not sure it's something that they will be able to do. There is a reason so far it's being explicitly said it's outside of the standard. With that, I think it's a combination. The big services that are a potential leaking endpoint, they should also do their part in trying to prevent themselves being part of that attack vector and protecting basically the businesses that are using them as services. So it should be part of the story. It can't be something that is just one way, one-sided. In practice, Google Analytics should also do something on their end to try and protect the users. It can't be something that only the browser does because they're a potential risk. It's not only them, but also them.
Any other questions? Prize.
Going once, going twice.
No? All right.
Thank you.